Hey, welcome to today's video where we are going to be focusing on how to simplify things called numerical expressions, and we're going to be using the order of operations. Now, I underline the word simplify because in an upcoming unit we're going to be talking about how to solve equations, but that's going to be later on. So I don't want to hear the word solve right now. We are just simplifying numerical expressions, meaning just numbers. We're looking at just numbers for today, and we're going to be using the order of operations. I wanted to remind you guys that in elementary school, you know about PEMDAS, and this year we're actually going to take that acronym and we're going to kind of level up a little bit, if you will, and we're going to talk about something called GERMDAS, and I can explain that back in the packet. Let me just get back over to the notes, okay? So the order of operations, again, it used to be PEMDAS, but now it's GERMDAS, and I just wanted to remind you guys that the order of operations is something that you need when simplifying expressions. If I were to pull up a recipe, which is for a grilled cheese here, and we're supposed to follow all of these steps, what would happen if you switched steps 3 and 4? What would happen if you, right here, put this before this? Obviously, the sandwich wouldn't be the same sandwich. So in recipes, we follow a certain order so that the meal will come out appropriately. Look at this example right here. This shows two potential ways to simplify an expression. One of them is wrong, one of them is right. Over here to the left, the wrong way would be if you subtract first, then multiply. So 12 minus 5 is the 7, then 7 minus 4 is 28. This is wrong because you went out of the order of operations. Now in PEMDAS, you learned that you're supposed to multiply first. So over here, the 5 times 4 goes first, which is 20. And now 12 minus that 20 would be a negative 8. So we're going to follow the order of operations, and yes, you can use your calculator for this stuff. And now let's dive on into the note taking. So first, when we're following GERMDAS, we're looking for anything that's grouped together using parentheses or even absolute value. So when I look at this first problem, right here inside these parentheses, I see 40 divided by 8. So I'm going to handle that first, and I'm going to write a 5. And then everything else I'm just going to write and copy down as was in the problem. So I'm going to be color coding here in my notes. The next thing we care about is handling an exponent, or now I'm going to put in a new word. It's an R for radical. And radical is actually the fancy math word for the square root symbol, y'all. So when you see here the square root of 64, that's a radical. An exponent is this little 2 that tells you how many times to multiply 5 by itself. Now you can actually handle these in the same step, or you could do them in 2 separate steps. You just want to go first from left to right. So for example, from left to right, I see that 5 squared here is a 25. Then I'm just going to leave the plus 10. Now I'm going to write the minus, and I have also here the square root of 64, which I know is an 8. So it is okay if you guys want to do those in the same step. Just go from left to right. All right, cool. So we took care of the grouping. We took care of our exponent and our radical. Now let's handle any multiplication or division. We actually don't have any, so it's okay to go to the last step here, which is addition or subtraction, just whichever comes first from left to right. So here I see a 25 plus a 10, which is a 35, and then I'm just going to copy down the minus 8. And in our last step here, when we do 35 minus 8, we're going to get a 27. So circle or box your final answer. And one thing I personally like to put is these little lines on both sides that kind of looks like it's funneling down to the right answer. It just kind of helps separate one problem from the next. So just to review real quick, PEMDAS is now kind of including a couple of things. Instead of looking at parentheses, we're going to talk about any grouping symbol. You might see the absolute value telling you to take absolute value of a negative 5. You also might see brackets in a few of the problems. So we're going to see more than one grouping symbol other than just parentheses, so that's why we're now calling it G. And then the R is a new thing for the square root symbol, so that's the radical. So G and R are the changes to PEMDAS, really. We defined a second ago an exponent. It's a number that tells you how many times to multiply. a number by itself. So a number by itself. Off to the side, let me just show you guys real quick. If you saw a 4 cubed with a 3 up here, that means to do 4 times 4 times 4, which would actually be a 64. Okay? You could do 2 cubed, which would be a 2 times 2 times 2, which is an 8. So the exponent just simply tells you how many times you're multiplying the number by itself. We've actually only seen squareds so far. So we already talked about earlier like a 4 squared. We've already reviewed that that would be like a 16. All right, and then the square root, once again, we already talked about the vocabulary here of perfect squares and square root. This thing's called a radical, and the square root of 64 is 8 because 8 times 8 gives you the 64. Okay, so this is just some vocab review right in here, and then the GermDOS steps listed out for you. Now let's try another problem over here. So inside our grouping, we actually have an addition problem. We're doing -13 plus 6. So if they have different signs, we actually subtract the two numbers and keep the sign of the bigger number. And that takes care of the inside parentheses work. Okay? So what I like to do is I generally like to underline the math that I'm about to do, and then I put the answer underneath it. And then everything else I just copy down from one line to the next. Now in elementary school, you learned that anytime you're subtracting a negative, that's really the same thing as adding. So at this point, when we see a double negative, it's really the same thing as just 32 plus 7, which goes on to be a 39. So 39 is the final answer to this one when we simplify. And now let's kind of just go over some basic adding and subtracting integers review rules. So anytime you have the same sign, like when I look at this, I see a -2 and a -8. If you lose $2 and then lose 8 more, you have lost 10 total. So anytime they have the same sign, you literally just add and keep. If it's two positives, just add and keep it positive. Now if they have different signs, you just simply subtract. So like an 8 and a 2, if I subtract, I get a 6. And then 8 here is bigger than 2, and 8's the positive number, so that's just going to stay positive. And think about it. If you're at -2, then add 8, you're going into the positives. Anybody who needs to see a number line real quick, if I'm at -2, so if this is 0, -1, -2, if I'm here at -2, and I'm about to add 8, let's see where I end up. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to end up right here at 1, 2, 3, 4, 5, 6. So -2 plus 8 is positive 6. All right, and then 2 minus 8. So again, they have different signs. This is a positive. This is a -8. So we're going to subtract. And since 8's the bigger number here, this one's going to be a -6. Now the thing we saw up here in the problem was this double negative. So anytime you see that, remember it's really just adding. And here I'm going to get a 14. Now I could start out with a negative number and then have to subtract like this. And if it's a negative number, don't forget that when you turn this into a plus sign, now you've just got to kind of ask, all right, do I have same signs or different? They're different, so I'm going to subtract and keep the sign of the bigger number, so that one would be a 7. Okay? So I just wanted to review some of the basic adding and subtracting integers rules. You will have your calculator to kind of help out with this stuff. But again, in the calculator, you'd actually have to tell it a 32 minus and then a -7. So let's make sure if you were putting that in the calculator, you do the 32 and then the minus, and then you tell it 7, but it's a -7 right here in green. So don't forget to tell that 7 to be negative, and you'll see that it knows to turn that into a plus and make it addition for 39. All right, now let's go down here and see one where it's just straight up a string of integers that we'd have to add or subtract. There's actually two different methods here. Some of you are going to go from left to right and say, okay, so from left to right, the first thing I see here, same sign, add and keep. And then you're just going to copy everything else down. And then minus the 7 and then plus 3. Cool. So then you're like, all right, from left to right, different sign, so I'm going to subtract and keep the sign of the bigger number. And then again, just copying everything else down after that. All right, cool. Now we have right here a -5 minus 7, so same sign, add and keep. And then a +3. And last but not least, since they have different signs, I'm going to subtract. 12 minus 3 is 9. Then I'm going to keep the sign of the bigger number, and I wind up here at a -9. Now, me personally, I actually would not do that to my brain. I don't like all of this. Is it same sign, add and keep, or is it supposed to be different sign, subtract? I don't like that. So if I saw all of this, I would actually see, okay, I have this -12 and this -4, and then this -7. And I put all those together, and again, this is where I'm getting it right here. I see a -12 and a -4, and then a -7. And then I also see right here a +11 and then a +3. So some of you might actually prefer to do it this way, where you chunk together the numbers. So I chunked together a -12 and 4 more negatives and 7 more negatives. There's all my same sign, add and keep. And then when I do this -11 and this -12, that's where I'm going to get this -23. All right. Now I'm going to take the positive, the +11 and the +3. And now I'm going to chunk that and make that a +14. So again, let me get my highlighter out just so you guys can see here. I just put together anything that was negative, the -12, the -4, and the -7. And even though they look like subtraction signs in the problem on their own, that's a negative. You can kind of see here when it's highlighted. And then I took those blue numbers, the positives, the +11 and the +3, and then just made that a 14. So now we can see here that I have a positive and a negative, so I just simply need to subtract and keep the sign of the bigger number. So 23 minus 14 is 9. This one's bigger, so we're going to keep it. And you can see we get the exact same answer. So when you guys see just a string of numbers like this, and it's all integers, and you don't see any multiplying, no exponents, none of that stuff, you can actually decide for yourself if you'd rather just go from left to right or chunk together the numbers. Just make sure if you're chunking together the numbers that the number has a symbol with it, either the plus or the minus from like right before, so that you know if it's a positive or a negative number and which chunk it goes with, okay? All right, now below it, we have one that has a fraction, and I didn't want anybody to freak out when they saw the fraction. With this fraction, you actually have a couple of different options. If you want to take a 1/4 of 16, in elementary school, you probably learned that if the second number doesn't have a denominator, to just put it over 1 and now multiply across. So 1 here times 16 is 16, 4 times 1 is 4, and now 16 over 4 makes it a 4. So that would be the final answer. Now, from the beginning, I can re-show you guys here this 1/4 of 16. If you see the final answer here, you might realize that taking a 1/4 of something is the same thing as straight up dividing by 4. So you could just do 16 divided by 4 in your head and be like, okay, the answer is 4. Now, let's say for whatever reason, you're just not feeling this fraction or division math. You guys know that 1/4 as a decimal is a 0.25. So you could use your calculator to do a 0.25 times the 16. And when you do that, you're going to see that you still get a 4. So worst case scenario, just make the 0.25 times 16, and you've got the 4. Okay? So that was just me handling the fraction part of this. But I didn't even really start with PEMDAS the way I should have. Let's go back up here to GEMDAS. I don't see anything grouped in here with the 16, so I can skip it. I'm going to go to exponent now, and right here I see an exponent. 3 squared is 9, so I'm going to go ahead and put that down. And then I'm just going to copy everything else down the way I see it. So a 1/4 times 16 minus 2, and then plus. And then we have a times 8 over there. So now we're ready for any multiplication or division, whichever we see first from left to right. And right here, I see the 1/4 of 16. We already know that that's a 4. Then I'm just going to do minus 2 plus 9 times 8. So we do have one more multiplication right here, which is a 72. Again, it's okay to use the calculator if you forgot 9 times 8 is a 72. So now we've got 4 minus 2 plus, And here, 4 minus 2 is 2. And we know that 2 plus 72 is going to be a 74. So the final answer for this one is a 74. Go ahead and circle or box your answer. And again, I like to just kind of draw these lines so I can see my answers getting simplified all the way down into one number. So you can see the title of today's notes are I can simplify numerical expressions. We're just dealing with numbers today using this order of operations. All right. Now let's look at this fraction question. That's what makes this one unique, is that right here there's actually a fraction bar. So we have a numerator and we have a denominator. So let's focus first on just the numerator, okay? So for the numerator, you have a 3 minus 5 times 3. So there's no exponents, there's no radical, just multiplication right here, and that's a 15. Be careful, in front of it is a 3 and then a minus that I'm going to bring down. And now since these have different symbols, I have a positive 3 and a negative 15, I'm going to subtract and keep the sign of my bigger number. So my top part over here is a negative 12. Now I still have this denominator to worry about, and it's a 9 times 3 minus 5 squared. So 9 times 3 actually is going to come after the exponent, so I'm going to leave 9 times 3 alone. 5 squared is a 25, so we're going to do minus 25. All right, this is a 27. The 27 minus 25 makes this a 2. So the denominator here is a 2. So if we have a top part and a bottom part, now let's look at this right here. And if we take the calculator and plug in here a 12, don't forget to make it negative. And if we divide that by 2, we get a negative 6. So the answer to this one overall is a negative 6. So anytime you see this kind of big fraction bar, you basically have two problems. And then when you get done with each of them, you come over here and then just do one more step to get the final answer. And for the last one here, it actually looks a lot worse, I think, than it really is. So there's, let's go back up here to GermDOS here and take a look. So we're looking for any grouping. And here the parentheses are actually used for multiplication. They're not grouping anything together with the 4.5. So there's nothing to do with the grouping. We took care of G. There's nothing there. I don't see any exponents. I don't see any radicals. I do see multiplication though, and it's right here, 2 times 4.5. Now 2 times 4.5 is a 9, and then I'm just going to bring down here the 10 minus, and then here, the 3/4. Don't let that fraction freak you out. Just go ahead and make it a decimal. All right, so we took care of the multiplication. There is no division. And now we're just dealing with the adding or subtracting, whichever we see first from left to right. 10 minus 9 is 1. And then we're just going to add a 0.75. So the final answer here would be 1.75. And since it started out with both a decimal and a fraction in it, you really could see either as fair game for an answer. Some might put a 1 3/4 here just to kind of keep in line with the fraction part. But again, there was also a decimal. So either answer here is acceptable. And if I were to have you type this into a Google form, you're going to go with this answer just because it's weird trying to type in a 1 and then a space and then a 3/4. Because if not, it'll end up looking like a 13/4. So we don't want to type that into the Google form ever. But just on your notes right here, that's fair game to put that down. But I'm sure you're going to see the 1.75 more often than not. All right. So today in our video, what we did was we looked at just numerical expressions and we simplified them. It started out with a whole bunch of stuff and we simplified it on down into one answer, one number. And that's what we did every single time. We just simplified it down into one numerical answer. And that concludes this video. Thank you for watching.